Let us look at the topic of factors and multiples. As we go on, we want to examine factors, including prime factors and composite factors. We'll also look at multiples, the highest common factor and the lowest common multiple. Now, a factor of a number is a certain number which can divide into that number, of course, without leaving a remainder, including 1. 1 is a factor of every number, and itself. A number is also a factor of itself. For example, suppose we have a number like 16. What are the factors of 16? In other words, we want to find out what are the numbers which can be divided into 16 without leaving a remainder. If we try 1 into 16, use long division here, 1 into 16, 16 times. 16 times 1, 16, remainder 0. So 1 can be divided directly into 16. So the first one is 1. Let's try 2. 2 into 16. How many 2's are there in 16? There are 8 2's in 16. 8 multiplied by 2 is 16. 16 minus 16, 0. So it can divide directly into 16, going 8 times. So there are 8 2's in 16. So 2 is another factor, can be divided into 16 without leaving a remainder. Suppose we try 3. 3 into 16. How many 3's are there in 16? 3 3's 9, 3 4's 12, 3 5 15, 3 6 18. There are 5 3's in 16. So we have 5. Multiply 5 by 3. And we know there is a little bit left over, but let's find out. 5 3 is 15. 1 15. This is 16. 16 minus 15 is 1. 3 cannot divide directly into 1. So what we can say is 16 divided by 3 is 5. And we have a remainder of 1. There is a remainder there. So 3 is not a factor of 16. Right? If you have 16 items, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You have 2's, 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 2's. So there is a set number of 2's in 16. Suppose we try 3's. 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 Are we going to cover these 3? Good. There's 1 3. There's 2 3. There are 3 3's, 4 3's, 5 3's. But we are not able to cover any more 3's because there's only 1 left over. So 3 is not a factor. 3 cannot go directly into 16. Now if you try 4, you will see that 4 is another factor of 16. There are exactly 4 4's in 16. 5 won't work. You will have 3 5's and 1 left over, so 5 won't work. 6, no. 6 multiplied by 3, 6 multiplied by 2 is 12. And you have 12, 13, 14, 15, 16. There is 4 left over. So you don't have 6 that can work. 6 cannot work. 7 cannot work either. 8. There are exactly 8 2's in 16. Any other? The only factor left is 16. So the factors of 16 are 1, 2, 4, 8, and 16. Good. Now, we want to look at what you call prime factors. But before we do that, let's be reminded what prime numbers are. The prime number is a certain number divisible only by 1 and itself. So example, there is 2, the only even number that is a prime number. There is 3. 4 is not a prime number because it has factors other than 1 and itself. 1 can divide into 4 directly. 4 can divide into 4 directly. Good. But 2 can also divide into 4 directly. So it's not a prime number. 5 is a prime number. 7 is a prime number. And so on. These are prime numbers. Now, we want to find out what are the prime factors of 16. Prime factors of 16. Okay, 16. 2 can divide into 16, so one of them is 2. Alright. Now, if you divide 2 into 16, you're left with 8. Right? So 16 divided by 2 is 8. Break up 8 into other prime numbers. There is 2 can work again, because 8 divided by 16 is 2. So no, means 16 divided by 8, I should say, or 8 divided by 2. Right, 8 divided by 2 is 4. So we can try 4. How do we break 4 up into prime factors? There is 2 again. Alright. Now, if you divide 4 by 2, you get 2. And what can divide into 2? It's 2. Alright. So, 16, the prime numbers that multiply, all multiply up to give you 16. There's 2, 2 again, 2 again, 2 2's 4, 4 2's 8, 2 again. Now, all these prime numbers multiply each other to give 16. So these are the prime factors of 16. 2 by 2 is 4, 4 by 2 is 8, 8 by 2 is 16. Okay, good. We can try another number. Suppose we try to find the prime factors of 30. Prime factors of 30. These will be prime numbers that are also factors of 30. Now we have 30. We can try 2 as the first prime factor. Now 2 by which number? Which other prime number? Let's see. We have taken out 2. We can say 2 by 3 gives you 6. By which other prime number? If we try 3, 2 3 6, 6 3 is 18. But I can tell you that another 3 will not work. Alright? What we can do, however, to find out further is like this. 30 divided by 2 is 15. Break up 15 even further. We already took out 2. 2, 3 is 6. However, we know that 3 can divide into 15. So 3 will work. The first 3 there. If you divide 3 into 15, you're left with 5. So 5 is another number. 2 3s, 6, 6, 5, 30, and all of these multiply out to give you 30. Good. If you had tried 2, 3, 7, 2, 3, 6, 6, 7, 42, that wouldn't work. If you had tried 2, 3, and 3 again, you would say 2, 3, 6, 6, 3 is 18. But you'd have to multiply 18 by something to give you 30, by a whole number, and that wouldn't work. Alright, so we want the prime factors of 30. We see which prime numbers all multiply out to give you 30. We try 2, 3, and 5, and it works. But instead of trial and error, we could divide the 30 by 2, and we have 15. Which is the next prime number that can divide into 15? It is 5 to give you 3. Or we could try 3 to give you 5, whichever way you want it. 2, 3, and 5, 2, 5, and 3. So try it by yourself and see if it works. So these are numbers which can divide into 30 without leaving a remainder. So these are prime factors of 30. Alright. Now, we mention composite factors. Let us just get rid of these to make space and look at this thing about composite factors, what this is all about. First of all, we need to know what a composite number is. Well, the composite number is all of those other numbers that are not prime numbers. They are composed of, or they have factors other than 1 and itself. For example, 6, 4, 6, any even number is a composite number. But guess what? You have another example. 15 is a composite number. 10 is a composite number too because it's even. But 15 is a composite number itself. Alright? So we have 15 as a composite number. Any number that ends with 5, it is a composite number because 5 can divide into it. Now, we might say, let's look back at our 30. What are the composite factors of 30? Okay. The composite factors of 30. We know that factors of 30 include 2, 3, which other number can go into 30? 5. We know that 10 can be divided into 30 because 10 multiplied by 3 gives you 30. We know that 15 is a factor because 15 times 2 gives you 30. We have reached the half of 30, so there are no more. So the composite numbers that can divide into 30 are these. Not 2. 2 is a prime number. We want composite numbers, not prime numbers. So the composite numbers that can divide into 30 are 10 and 15. The prime ones the prime numbers that can divide into 30 are 2, 3, and 5. So the prime factors are 2, 3, and 5. The composite factors are 10 and 15. Okay, good. Now let's look at one more. What about the number 50? Let's take out the composite factors and the prime factors. What are the factors of 50? Other than, oh, guess what? 30. There's 30 itself as a composite factor. Alright? Now, let us look at the factors of 50. 1, there's 2. 2 can go into 50. Not 3. What about 4? No. What other factors of 50 are there? List them and tell me what you get. You finished? Okay. And by the way, we won't include one as a composite nor prime factor. Alright? So, what were they? Did you include 5? Did you include 10? What was the next one? 25. Okay? These can all divide into 50 without leaving a remainder. See, 2 times 2 times 25 will give you 50. 3 won't work, 4 won't work, 5 will work. About 6, 7, 8, 9, those when you divide into 50 you will get a remainder, or you will get a number point something. 11, 12, 13, 14, no, 15 will work. No, not 15. And you go up to 16, 17, 18, 19, 20, all the way up to 25. That's the next one. So here, those numbers that are factors of 50 and prime numbers, and remember the 50 itself is another factor. The prime numbers here are 2 and 5. If you want all the prime factors of 50, they will include 2 and 5. You have 2, 5, 2, 5, 10. 10 times what give you 50? Another 5. 2, 5, 10, 10, 5, 50. These would be the prime factors of 50. Composite over this side. The composite ones would be, there is 10, there is 25, and there is 50. These are all composite factors of 50. Alright? Now, what we want to do next time is look at what are called multiples. So we'll save multiples for the next video. I'll see you then.